In this video, we're going to look at a quadratic application. In this case, we have an equation here, h equals negative 490t squared plus 1470t, that gives us the height h in centimeters of a golf ball t seconds after it has been hit. So right away I'm going to notice there's no constant term in this quadratic. So when t is equal to 0, finding the height should be pretty easy. Actually, it's easy whether the constant term is 0 or not, because it is always just that constant term. In this case, that constant term is 0. But I'm going to go ahead and write this out by plugging 0 in for the values of t. I can see I'm going to get 0 plus 0, which is 0. So that tells me that the point 0, 0 is on my graph, which is alluding to the fact that before I hit the golf ball, before the golf ball takes flight, it's on the ground. The height is 0. So what we want to do now is finish filling out this table to find various heights of the ball after various times. And this is basically a calculator activity, or you could use Desmos to help you build a table. But it's good to go through the first couple by just plugging them into your calculator so you can make sure that you're following your order of operations correctly and all that good stuff. So why don't you pause the video and find these values by plugging in t to this equation and finding various heights at these times, and then unpause the video when you have the table complete. All right, take a look at the table. Are these the values that you got? So you should start to notice something interesting here, some symmetry in this table. My y values, my height in this case, start to repeat themselves here. These are both 980. These are both 612.5, and these are both 0. So when we see that happening in our table, that point in the middle of that symmetry is a very important point, right? That point is our vertex. Okay, so the next thing we want to do is graph this information. So the big important thing here is to choose an appropriate scale. We need to go all the way up to 1,100, a little bit above, and our time, basically after 3 seconds, what happens? This ball hits the ground. 3.5, this came out to be a negative, so that basically tells us we don't care about that point. That's not the ball below the ground, right? This is just telling us that really this part of the table up to 3 seconds tells us about the flight of the ball, and then anything after 3 seconds is not really applicable to this problem. So I need to choose a scale where I'm just going from 0 to 3. So I don't really want to make each of these worth 1. That's too squished. I want to spread this out, and then I need to pick a scale so this goes up to 1100 at least. So we'll just start by drawing our axis and labeling each axis with the correct variable t and h and the correct unit of measure, seconds and centimeters. And notice here how I've only used the first quadrant. In this situation, my values are positive. I don't care about t being negative or h being negative, so that limits me to the first quadrant. So now to spread this out a bit, maybe I just go like 4, 1, 2, 3, 4, and make that 1 second. So every quarter of a second, make that 2 seconds, 1, 2, 3, 4, make that 3 seconds, something like that. That's going to help. And then we have our 0.5, 1.5, 2.5. And let's see, what if we go by hundreds? I think 50s, there's not going to be enough room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah. So maybe I'll go by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, and a few more like that. All right, so now that I have an appropriate scale set up and marked, I'm going to go ahead and plot my points. So why don't you pause the video and plot your points as well, and unpause when you're done. Alright, so there's my best freehand of my parabola there. So we plotted the points in the table, those are marked here, and then when you sketch your parabola, just make sure if you don't have a lot of points near the vertex, make it, more sort of U-shaped. Don't go like pointy up there. It's usually very smooth and U-shaped up there. So I see some really important things here. I see my axis of symmetry where I expected it to be. I see my vertex, which is at 1.5 seconds, whatever that value was. What was it? Oh yeah, 1,102 point something, 0.5. So my axis of symmetry is x equals 1.5. All right, so what is the maximum height of the golf ball and when does it reach that height? That's my vertex, right? So we have a max height of 1,102.5 centimeters at t equals 1.5 seconds. And that's my vertex. So whenever you see this like maximum or minimum, if the parabola is doing this, it will have a minimum value. It's talking about the vertex. It's asking for the vertex. It's asking specifically for the y value of the vertex. All right, so just to practice and verify, let's find that maximum height using this x value of my vertex formula. So let's rewrite our equation. Negative 490t squared plus, what was it, 1470 t. Okay, so what is my a value and my b value? My a value is negative 490. That's the coefficient on the squared term. And my b value is positive 1470. So the x value of the vertex is the opposite of my b value divided by 2 times my a value. All right, so why don't you grab a calculator and plug that in, and hopefully, what are you expecting to get? Hopefully you're going to get 1.5. And we do get 1.5, which is great. So now, I guess now to find the y value of the vertex, which is our maximum height, we would just plug in 1.5 for t into the equation, and you know what? We've already done that in the table. We've already verified that, so there's really no need to do that again. And it is 1,102.5, in this case, centimeters. All right. Well, I hope that example helps you with your quadratics.